Yesterday I have this recording, history of computing, and then ENIAC and Alan Turing. So you have your class, the date and the section and the topic being discussed. Okay, so that it will be easy for you to locate. Right, usually it will be right after the topic that is being discussed. Okay, any questions so far? No. So your assignment is due on Monday. Okay, ito. Okay. This June, August 1, before 8 o'clock. I'll check this over the weekend, by the next weekend. Any questions so far? So do you
Sir,
yes.
may question po ako regarding sa operation card and yung combinatorial card po, yung CB and CF.
Yes.
Yung sa sir ba, yung sa reference na gisend mo, yung sa analytical engine programming cards.
This one. This one?
Yes. Yes, sir. Sa
yes.
Combinatorial section po. Combinatorial card section sa baba.
Yes.
Nasa baba pa po.
Okay. Yes. Yeah, this one. Backing
yes.
and advancing?
Yes po. Sa baba pa po, sir. Merong example pa sa mas baba pa dyan.
Ito.
Yung CB11 po.
Yes.
So, ang sinabi kasi dyan po na kanang mag-start daw og count after the CB11.
Oh.
So meaning below that dyan mag-start mag-count. So i-count mo siya 1 from 1 yung CB11, 2, L0, 3, L2, 4, S0, L5, 6, 7, 8, 9, 10, 11. So yan po 11 siya po, sir. So
okay. Kulang ito ng isang linya, right?
Pero ang sinabi po sa sir, like on the later paragraph, sabi niya since nabasa naman daw yung CB11 na card, meaning mag-proceed na daw siya sa next, pero from that next card dyan mag-start ng CB count or mag-count backwards.
So tama, if you start at before, nakasabi ba dito before? Where's that?
After po, sir. Yung after sa yung parang may plus and question mark. After that paragraph dyan po. After that question mark na
the third character includes
after that, sir.
Okay nga. After, plus.
Yan, the number state. The number starting that column 4 indicates how many cards are to be advanced, pass, or back up the pass the reader. To understand this number, it is important to keep in mind the time the card at the time the card. Sir. So, yung parang may naka-italicize po, sir. May naka-italicize po dyan.
Correct. If you are going, that's why he excluded the minus here. Do you follow? Kasi if you count without the minus, it will be exact. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right?
Okay, sir.
Okay, so it's a convention. It depends. For me, it will be easier if you write the minus here, because you don't know what operation is being done here, and then start counting at the beginning here. Dito ka magbilang. Well, it will be correct, but in our succeeding demonstrations, what will happen if you have, kasi ang kulang dito, wala siyang, it didn't have a minus. I've seen that before, but I'd rather that we have the minus and then start counting from here. Do you follow?
Yes, sir.
Because this is confusing. If you do that, you just remove the minus, okay?
Okay, sir.
So if I were to do it, I have corrected this myself because this is confusing, the minus here, Because what operation? Because all command starts with an operation card, okay? With the operation, do you follow? Kasi when you just say load will just transfer, okay? But it will not do anything if it's not preceded by an operation card, okay?
Okay, sir.
So it will be very confusing, especially in your succeeding programs, if you will start counting and then you will not have a minus. Okay, you can do that, but you should be careful with this, no? Ito, because this will miss you the count. Okay.
Where the counting starts or parang ma-include.
After man sa kanya, that's why it will be correct. Because
Oh,
it
yeah.
will start counting from here, the next line.
The next card,
Right.
yeah.
So which for me is confusing. If I were to do it, I'd rather put the minus and then start counting from there. Do you follow?
Yes, sir.
Okay. Okay. Magulo kasi yung ano, it will not change the accuracy of the program, no? If you will have a minus from here.
Okay, sir. Thank you, sir.
Anyway, no, nakita ko na rin yan before, but I found it very confusing. Okay, it's more straightforward if you have a minus there and then start counting. Okay. Kasi by the way, no, the analytical engine was never implemented physically, no. The programs that we run were just simulations, no. So these were subject to improvements, no. Okay, you can do that if you like, no, but I'll have to check it manually myself anyway, no. So thank you, no, for the no, for getting my attention on that. In fact, no, if you look at the sample programs, other sample programs, they always start with an operation card. Okay, it's good that you have read this in detail, no? Okay. So anyway, let's proceed, no? We discussed the analytical engine and we have discussed the design. No? Mainly, it has the mill, no? The mill has three main. Asan ba yung ano? I'm sorry, no? Ito, no? The mill has three main axes. Nowadays, we call this axis as registers. Do you follow? We call this as the ingress register 2, egress register. A register is a device that can be used to store a numeric value. Do you follow? Okay. So this is now called registers, especially in the succeeding inventions where electronic devices are used instead of gears. No. Now, even in a cash register, no, it's actually a set of wheels. No, each column is called a register. Okay. So have I told you the story of ano, Ada Lovelace?
Briefly lang, sir.
Huh?
Briefly lang. Not in detail.
Not in detail. So let's go through that, no. So this because during that time, no, without Ada Lovelace, nothing could have happened with the invention of Charles Babbage. Do you follow? It was scuffed out by most or all of the scientific community in the university then, because remember that Charles Babbage is a professor, a location professor in Cambridge University. No? He is a mathematician. It was not mentioned whether he is also doing physics or not, but most probably he's doing that because he's doing mechanical calculations. No, do you follow? So this was discovered by Ada Lovelace. The work was discovered by Ada Lovelace. Okay, such that she published also an actual work using the machine. No, I've shown you the worksheet by
Yes, sir. Ada Lovelace.
By Ada Lovelace. No, a very crude worksheet. No? Okay, which we are trying to follow. No, so that was she published that in. I don't think it was ACM, but in one of the publications they have, no, belonging to scientists. No, and then Charles Babbage, of course, no, read the publication and thanked, no, and sent a letter to Ada Lovelace thanking her for recognizing the importance of his work. No? So, nandito. Okay. Okay. University of London, no? Mathematically, they were able to discover the chart by the work of Charles Babbage. Okay. There was a person, a teacher, no, Augusto de Morgan, also maybe the author of de Morgan's theorem during that time, no. I think, no, he's not only a friend of Babbage but also the husband of the daughter. So there was a connection between Ada Lovelace through another professor, Augustus de Morgan. Okay, is that correct? So where's the letter? Let me look at the letter now. This is the letter, no? Hindi masyadong maintindihan, no? Okay. Is this Ada Lovelace letter? Okay. Ito. This is the letter, the first letter by Charles Babbage, no? Recognizing or thanking Ada Lovelace for recognizing his work. And at the same time, no, right after, no, the next day, she wrote again, no, for a final revision, okay, that she suggested to be made on the analytical engine. Okay. So there was a correspondence between there was an actual correspondence between Ada Lovelace and Charles Babbage. Okay. Unfortunately, no, 2 or 3 years, a few years after, no, the work done by Augusta Ada King, she got sick and she died shortly thereafter. Okay, so ito yung kanyang formula, no, for this is the actual worksheet. I've shown you this already. Okay, so nandito yung mga operation, nandito yung variable, working variables and results. Okay, you can read this, no, and you can also look at the videos, no. Do you follow? Okay, it was very unfortunate that Ada Lovelace died young because after that nobody paid interest anymore to the work of Charles Babbage. They follow, and the computing technology entered another dark ages, but only for less than a century. Okay, no, 18 that was 1800s, diba? Pagka 1900s there were developments already, okay, regarding computing and computing technology. Okay, any questions so far? Now what followed, we look at these two slides, these two sources, no. What followed the analytical engine? Because since it is an evolution, what followed the analytical engine? No? So this is 1837. No? The analytical engine was introduced. It was never fully developed, no? Although a small version was developed by Charles Babbage. In 1909, a certain professor, no, Percy Ludgate, I don't know where she's from. He's from, tingnan natin, no? Scientist. He redesigned, no, and created a second analytical engine based on based on the work of Charles Babbage. So he added certain components such as a multiplier accumulator. Okay, but the term accumulator was formally defined, no, later in the 1940s in the ENIAC computer. Do you follow? So this 1909, a significant improvement in the version by Percy Ludgate. Nasaan ba siya? He's a scientist, no? Which university? Hindi naman sinabi, no? Maybe he's just an inventor, no? Mechanical computer design. Okay. They follow. So anyway, so much for that, no? One of the notable improvements was the use of physical state of rods. They are magnets, no? Magnetic rods, whether they're magnetized or not. In 1939, during the start of the World War, no? Konrad Zuse from Germany invented the Z1. Okay, the Z1 was the first mechanical computer which is based on the binary number. Do you follow? And much more than that, hindi binary fixed point, but really binary floating point representation. We will talk about that later, no? In one of our lectures, no? Floating point and fixed point representation. Okay, and then okay. Also during that time, by 1940, when the World War has already started, no, an invention from Poland, invented in 1949, was transferred to the British, no, was transferred to Great Britain. It was called the bomb. Okay, the bomb is actually a mechanical machine. Okay, is it binary? We'll look at that if it's binary, no. Okay. Walang nakasabi, no. But the inventor of this machine the invention of this machine was accredited to Alan Turing. Do you follow? Okay. So the design and construction was of Harold Keane, no? And British tabulating machine. Okay. Because this was okay. The initial design of the brick was produced in 1939 at the Code and Cipher School at Bletchley Park by Alan Turing. Okay, so the main design was accredited to Alan Turing. What is Bletchley Park? Where is Bletchley Park? Bletchley Park is a secret place designated by the British military where certain researches, no, important researches were done. Okay, especially during that time, one of the most important researches was hacking the Enigma code. Okay, you know what the Enigma machine is? Anyone? What is the Enigma?
German, sir.
Huh? This is a typewriter or an encryption machine invented by the Germans, Nazi Germany, no? Do you follow? So that they can communicate with their troops in the field very quickly. So instructions, messages, commands, no, sent to the troops in the battlefield are encrypted using an automatic encoding machine, no, encrypting machine. They follow called the Enigma machine. Who invented this? Arthur Scherbus, no? In Germany. Okay. In 1918 pa, no? This one is invented in 1918. Okay. And who broke the Enigma code? Okay. The British government cryptology establishment at Bletchley Park. It was a secret mission, no? And the team was held secret, but nowadays people know that the team was headed by Alan Turing. And the main code breaker was really Alan Turing. Do you follow? So the Enigma machine works in such a way that, no, a secret key is preset into the machine before typing a message. Do you follow? Such that the succeeding letters composing the message will be in an encrypted form, And you cannot read the message unless you know the key. Do you follow? Okay. So the message is sent, the written message is sent, and then the key also is sent separately. So that when the recipient gets the message, he has to encrypt it himself. I'm not sure if it's also the Enigma machine, no, that is used to encrypt and will be able to interpret the actual message. Do you follow? Now, Alan Turing and his team recognize that once a character is encrypted, no same encryption will happen even to two different keys with the same key. Do you follow? All keys will have different encryptions. Do you follow? And then they made use of this loophole kasi nakita nila na nothing repeats even if the nothing repeats for the encryption of a certain character. Okay, but since the messages are common, like German messages starts with good morning, good day, and then respectfully yours after, they were able to create an algorithm that will decipher the messages. However, the computations required are very long. Okay, it will take them days to interpret or to encrypt short messages. Do you follow? So that was the main difficulty of the team at Bletchley Park. So to alleviate this, Alan Turing used the bomb from Poland, reinvented it, and used it to hasten the calculations required by this deciphering process. So cipher school. Okay, so by which they were able to crack the Enigma code. Do you follow? Alan Turing was accredited to be the main hero of the Second World War, because through his invention, they were able to predict the plans and moves of the German Nazi military, and then they were able to cut short the war in 3 or 2 years, according to because of the decryption of the Enigma code, the war was won in 3 years time, in lesser than 3 years time. Do you follow? So Alan Turing was considered to be the main hero of the Second World War, such that the invention of Alan Turing was later acquired by the US. Okay, there was no formal but in Wikipedia it will show you that Alan Turing invented the bomb. Okay, we'll go back to that later. And then in 1940, the Zeus Z2, Conrad Zuse, introduced an upgrade to his computer. The problem with Conrad Zuse's invention is the main market of computers during that time is the US, and the US do not usually buy technology from others during that time. They will have to invent them themselves. So it was not published it was not marketed in the US. Okay. And by May 1941, binary floating point, and the computing mechanism for the Z2 is electromechanical, so part electronic and part mechanical. The memory is made of physical state of rods, or magnetic rods, and then the program is controlled no longer using this is no longer using like its predecessor, the Z1. It uses a film, a film for photography, old films, instead of the traditional Jacquard's loop. Okay, 35 mm film stock. Okay, the Z3. Okay, it was very advanced, because later, the film technology was also used, as storage in the succeeding computers. Now, Z3 uses mechanical relays for its memory devices, for its memory. Okay, in principle, it was considered to be Turing complete. What is a Turing complete machine? A Turing complete machine is a machine whose behavior can be fully mapped it can be fully predicted. It's like a program without bugs. Do you follow? No. So this criteria was defined by Turing when he devised, or when he formulated mathematical models for computing. Now, Alan Turing is the father of mathematical computer science, no, and artificial intelligence. Okay. Now, in the US, there was a tight competition. Okay. During the middle of the war, no, the universities there were racing to produce the first electronic computer. Do you follow? Not only the universities, but the inventors who are mostly teaching in the universities. No? So in 1942, no, in Iowa State University, a mathematician, physicist, no, John Vincent Atanasoff and Clifford Berry, no, from Iowa State University, introduced what is now considered to be the first binary computer. No, there was a debate, there was a controversy, no, on who really, what it really is the first invention. Okay, but it was later declared that ABC computer by Atanasoff and Berry is the official first electronic binary computer. The only problem with that is the invention is really not programmable. It was wired to perform a particular computation. Okay, do you follow? But it's already electronic and uses capacitors, no, for its memory, like the modern capacitors that we use nowadays in our memory devices. Okay, so this is the beginning of all memory-based, capacitor-based memories. Do you follow? We'll find out why, later, why there was a controversy and issue on who really, or what really is the first official electronic computer invention. In the US, electronic Colossus Mark I, in the UK, by the way, was introduced in 1943. It was a binary computer and uses thermionic bulbs, vacuum tube diodes. Okay, ito yung Colossus Mark I, no? Mark II pala ito, no? The significant characteristic is that it uses vacuum tube diodes. What are vacuum tube diodes? Vacuum tubes. So not just diodes, but there are also vacuum tube transistors. Ganito, no? They are binary devices, which means that they can store 0 or 1, right? But this time they're using vacuum tubes, no, to store the electromagnetic charges that are needed to switch the transistor from on to off. Do you follow? So this time, no, magnetic rods are no longer used; they are replaced by vacuum tubes. Now, Howard Aiken in Harvard also introduced the mechanical version of the analytical engine. Okay, this is their attempt to reproduce, no, the work of Charles Babbage. This is said to be electromechanical. This is already electricity, no, but most of it are made of rotating gears, no. So patterned after the analytical engine in 1837. Okay, this is Harvard Mark I, produced by Howard Aiken from Harvard University. Howard Aiken is a scientist in IBM, but also affiliated with Harvard University. Harvard University was the first customer of IBM in the case of Mark I. Now, it was then that in 1944 that the term bug was coined. It's a jargon, no, that was added to the long list of computing jargons. No, when you say a bug, nowadays we mean an error in the program. No, however, during that time, no, when they noticed that the Mark I didn't work, Upon inspection, they found out that a moth was caught in between the gears, so they call it a bug. So when something causes the Mark 1 to malfunction, they will start looking for bugs. Okay, just in the same way that nowadays, no, when a computer program starts behaves abnormally, no, otherwise, other than it's designed, we start looking for bugs. Okay, Z4 in 1948, it was a binary floating point, no, no, it's no longer fixed point, no. Electromechanical, it's a first generation computer, what never used in the US. Okay, uses mechanical relays for its memory. Now, a very important development in the US came after the war, no. This was ENIAC, because ENIAC for a long time was considered to be the first electronic computer. Okay, but they were sued, no. In fact, the inventors of ENIAC tried to apply for a patent, but the patent was later withdrawn from them. ENIAC stands for electronic, numerical, and accumulator and calculator. Electronic, numerical, integrator, accumulator, and calculator. Is that correct? Electronic, numerical, integrator, and computer. So, nawala yung A. But there should be accumulator because the main component of the ENIAC is its accumulator. Do you follow? Now, this is also another jargon added during the time, the term accumulator. ENIAC is very significant nowadays because it's an electronic computer which is based on the decimal system, and it uses vacuum tube diodes. It's Turing complete. They like Charles Babbage, no? So it's very close to Charles Babbage analytical engine. The main difference is the physical, the physical characteristics, because the ENIAC is electronic and the analytical engine is mechanical. Okay. And then there was an issue here on who really invented the first machine in the US, electronic machine. And later, no, Manchester Baby was invented. I think this was invented by the same group at it is an upgrade of the bomb, no? Do you follow? Okay. It is the next, no, it is a predecessor of the bomb used at Bletchley Park. Do you follow? No? So ito yun, no, ang brief history, no, in both of the UK and the US, no. So 1884 was the invention of the punch card, and 1904 is the invention of the vacuum tube diode, which was later used, no, in ENIAC, no. Herman Hollerith founded the IBM. It was then named Computing Tabulating Recording Company in 1911, was formally renamed IBM in 1924. So electrically powered mechanical analog computer was introduced in Great Britain in 1912. Bonnie Barbush at MIT. Harold Locke Hazen. MIT ito, no, constructed a practical general purpose differential analyzer. We don't know what it is, but it is for differential equations. So in 1937, it was then that what is considered to be the first electronic digital binary computer was introduced by John Vincent Atanasoff and Clifford Berry, completed in 1942. 1947, Mark I in IBM. Okay. Pattern. The Mark I is patterned after the analytical engine. Okay. Hewlett Packard was founded in 1939. Bell Labs, which is actually now AT&T, okay, started using relays for demonstration. Addition, no? Binary addition. The complex number calculator was completed in 1940. CNC, no? So Conrad Suss in 1941, Z3. And then the Mark I was completed in 1944. And 1945, ENIAC was invented by John Moakley and J. Presper Eckert in University of Pennsylvania's Moore School of Electrical Engineering. ENIAC stands for Electronic Numerical Integrator and Calculator. It was a decimal computer with a close resemblance to the analytical engine. We will not program this, but we will look at the design. Okay, we follow just to show the evolution. Okay. Tingnan mo. Can you look at these videos, no? This is the ENIAC computer. Do you follow? It is made of, it is a, okay, it is a it's an electromechanical device. Okay. Patterned after Charles Babbage, no? The main difference between the Mark I and ENIAC is Mark I is purely mechanical. ENIAC is largely electronic, no? Although there are still mechanical parts. Okay? Ito yung design ng ENIAC, okay? It's good to look at the story of ENIAC, no? So that you will know the controversy behind. Okay. The input of ENIAC is taken from an IBM card reader, and an IBM card puncher was used for output. So it replaced the traditional, the old Jacquard loom. Initially, ENIAC had no memory or store, but in 1953, Barrows Corporation introduced a 100-word, so it can now store 100 numbers in its memory. It's much smaller than the design of Charles Babbage, because Charles Babbage's design is 1,000 words. ENIAC used 10 position ring counters to store digits. So ibig sabihin, each digit uses 10 ring counters. Do you follow? Do you follow? So the a ring counter is a relay-based. It's not a gear-based, no? Relay-based device which can record 0 to 9. It had 20 10-digit assigned accumulators, no? Which uses tens complement representation, okay, and could perform 5,000 addition and subtractions. No? Programming the ENIAC was done manually by setting switches and connecting wires on a plug board. Saan ba yung ENIAC? If this were ENIAC, this is the CPU. These are the plug boards, okay, used to write the programs to run on it. Here's a simple comparison, no, to show the evolution between ENIAC and the analytical engine. For input and output, the analytical engine uses Jacquard looms with punch cards. For ENIAC, it uses IBM punch cards for input and output, card reader and card puncher. Now, the main CPU of the analytical engine contains 3 registers, 2 ingress and 1 egress. On the other hand, no, the ENIAC uses 20 accumulators. What is an accumulator? Because the inventors of ENIAC realized that why exclusively set a function for a register? Why exclusively limit a register for input and limit a register for output? They do not find that practical. So they invented a new device, a new type of register, a register called accumulator. Do you follow? An accumulator is a register that can be used for input and output, both at one time, no? One at a time, no? So at a certain instance, the accumulator A can be used for input. At another instance, it can be used as output. The number system being used are the same, fixed point decimal, both for the analytical engine and ENIAC. Programming, in the programming aspect, the program is sequentially stored in punch cards through a Jacquard loom in ENIAC. or rather in the analytical engine. For ENIAC, no, programming is done by setting switches and plug boards. The programmer of ENIAC is Countess Ada Lovelace. Now, the programmers of a rather analytical engine, I'm sorry, no. The programmers of the ENIAC are all women because there are no men programmers at that time. They're all fighting the war, no. The ENIAC was implemented with 18,000 vacuum tubes, 1,500 relays or transistors, 10,000 capacitors, and 70,000 resistors, occupying a room which is about 1,800 square feet. The inventor is Charles W. Babbage, 1937. ENIAC was invented by J. Presper Eckert and John Mauchly in 1946. Moore School of Pennsylvania State University. Remember, Penn State is a very popular school, no? It's where Donald Trump came from. No? So Penn State, until now, is organized into different schools. Like the business school is the Wharton School of Business and Economics. The engineering school is the Moore School of Engineering. This is where J. Presper Eckert and John Mauchly were working as teachers, no? Okay. Now, there's a controversy. Let's look at that, no? What did Alan Turing say about ENIAC, EDVAC? Kasi tatlong main computers during the time, no? EDVAC, ENIAC was sidelined, by the way, no? ENIAC and EDVAC, and then there's the ABC computer, and then there's the IAS computer. Okay, so they are called, the EDVAC and IAS are Princeton class computers. No? IAS is from Princeton University. Its main inventor is John von Neumann, also about the same time. We look at this computer more closely. No? And then ENIAC and EDVAC were invented by Presper Eckert and Mauchly. And the ABC computer was invented. Presper Eckert and Mauchly are from Penn State. And then the ABC computer was by Clifford and Berry. Clifford Berry and John Vincent Atanasoff, no, of Iowa State. So there are three main universities. They were competing to be the first electronic computer, binary computer during that time. What did Alan Turing comment? Kasi there already was the ACM. The ACM is the main publication that is used to publish, no, results, no, or scientific work. Okay. Ito ang sinabi niya. He was trying to address this to Presper Eckert, to von Neumann, and John Berry, Atanasoff and Berry. No? Kasi they were haggling. They were trying to, you know, outmatch each other as to who really is the inventor, the real inventor of the computer in the US, no? So ito ang sinabi niya. The idea of a digital computer is an old one because Presper Eckert, mainly, no, the group of ENIAC is claiming that this is a new machine. Okay, this is a new idea. So Alan Turing raised an objection that the idea of a digital computer is an old one. Charles Babbage, location professor of math at Cambridge, planned such a machine. So he told them that's already been discovered, called the analytical engine. Although Babbage had all the essential ideas, this machine was not at the time such a very attractive prospect. The speed at which calculations would have been available should be definitely faster than a computer, human computer. So he's saying that the speed at which the analytical engine could do computations is something like 100 times slower, it's faster than a human doing the calculation, but 100 times slower than the Manchester machine. What's the Manchester? That's the Manchester baby in UK, right after the bomb. It is one of the slower of the modern machines. Manchester baby is considered to be one of the slower itself. One. The storage was purely mechanical using wheels and cards. Now, meron siyang stark revelation that follows. No? The fact that Babbage's analytical engine was to be entirely mechanical will help us to rid ourselves of superstition. No? It's by superstition he means extra ideas, unfounded ideas. No? Importance is often attached to the fact that modern digital computers are electrical. You're saying that, no? And the nervous system is electrical. Since Babbage's machine was not electrical, and since all digital computers are in a sense equivalent, we see that the use of electricity cannot be of theoretical importance. And sabi niya, being your computers as electrical as they are, it's not important. Okay? What is important is the idea behind. Okay? In certain computers, the storage system is mainly acoustic. The feature of using electricity is thus seen only as a superficial similarity. Okay? Yun yung sabi niya. Okay? He was trying to criticize J. Presper Eckert and John Mockley. And John von Neumann, and of course, included na si, there was a case that was filed in court, and which really was a conviction was delivered, no? As to who really is the real inventor of the first binary computer. A case was filed, and it was a very popular case. No? It was overshadowed by the it was all over TV, no? All over the news. It was overshadowed only by the assassination of John Kennedy. No? Any questions so far? No, that's the story. No? Watch this video on the ABC computer because it will show you, I think, now the components like the arithmetic logic unit, the binary, the use of binary floating point and fixed point. So, father of computer science, theoretical computer science and artificial intelligence is awarded to Alan, is now recognized, is now awarded, is accredited to Alan Turing. Now, who is Alan Turing? Alan Turing is a mathematician who did mathematics in Cambridge University, the same university that Charles Babbage taught a long time ago. And then, right after finishing his bachelor's in math, he proceeded to a PhD in math in the US. No? So he's known to be a computer scientist, a logician, cryptanalyst, philosopher, and theoretical biologist. No? He finished his PhD in math from Princeton University in what? 1938, I think. No. Okay, just before the Second World War. He obtained in 1938 in Princeton University. Now, take note that Princeton University is where the IAS, Institute of Advanced Sciences computer, IAS computer was invented also. It was invented by a professor named John von Neumann. They almost know. So it's either there because John von Neumann taught at the Princeton University from 1930 to 1933. 1938 siya nagtapos. They must have seen each other there. Okay. So he was mainly accredited for the victory of the Second World War by the Allied countries, against Germany and Japan and Italy, for his breaking of the Enigma code. He broke the Enigma code. What happened to, like Ada Lovelace, Alan Turing died at a very early age, 41. Ganon din si 41 din si di ba? Ada Lovelace. It's very bad news because his early death meant a lot of undiscovered work to have been developed. Okay. How did he die? He died. During that time, a different gender preference is considered a disease or an illness. If you are a gay you are considered sick. Do you follow? And then he was sued in court for a crime that is no longer considered a crime today. It was called a crime of indecency. You know what it is, no? It's a sexual practice of a different, of an abnormal preference, no? Same-sex sexual practice. So they considered it indecent. And during that time, no, in the 1940s, it's considered a crime. Okay, he was sued in court, so he was supposed to serve prison, but since he was considered a hero of the war, he was given a minor penalty. Instead of going to prison, okay, he was given a certain hormone, no, to possibly treat to what they thought was an illness. Okay, and Alan Turing did not accept it. No? He was so humiliated that a few days later, no, after his conviction, he killed himself he took his own life, no, by taking cyanide poisoning. However, in 2009, no, the British Prime Minister Gordon Brown made a public apology to all those convicted of indecency, because they withdraw. No, it was not, they illegalized, they removed, no, they withdraw the decency law in the Great Britain, and Gordon Brown made an apology in behalf of the British government. No, they made legislation to take away the decency law, no, to consider it illegal. So they call it the Turing's law, no, Alan Turing law, informal apology to Alan Turing. No? And at the same time, Queen Elizabeth II granted a posthumous pardon to all those convicted of indecency in 2013, which means that you are not an offender. You are not considered an offender if you are guilty of indecency. Okay? Do you follow? So that's the story of Alan Turing. You look at the demonstration of the Enigma machine, you'll see the encryption process there. And later, no, after the turn of the millennia, no, BBC, British Broadcasting Corporation, made a research to determine who really is the recognized person, the greatest person in the 20th century. Do you follow? This is the media research, BBC, in a television series. Okay, and upon their survey, they had listed candidates, okay, of the greatest person of the 20th century, 1900s. Nelson Mandela, Margaret Thatcher, in different fields. Okay, and in the end, no, after a long process, no, of this was aired in TV, of determination, they awarded the greatest person of the 20th century to Alan Turing, above, no, Albert Einstein, Marie Curie, no, is that Marie Curie, no, okay, Neil Armstrong, no, they awarded the greatest person award of the 20th century to Alan Turing, no. So this the, no, you watch this video on Alan Turing, no?
The greatest person, the 20th century.
And that person is? Alan Turing.
Okay. Okay. Now it was a group, no, of legitimate scientists, no, and professors and universities, no, that contributed to the recognition given to Alan Turing. Okay. Any questions so far? So tingnan na natin ito, no? Look at this, no? The ENIAC computer, we have seen this. And then, okay. Next meeting, we will introduce a new topic. It's called the stored program concept. It's also a computer almost of the same age as ENIAC, no? And EDVAC, no? But introduce a new concept. But this concept was implemented in EDVAC. Do you follow? There was a race to produce the first stored program concept, the Princeton class computer. During those times, no, there are two classes: Harvard class, which is Mark I, and Princeton class, which is IAS. No? We will describe what the stored program concept is all about, and we will look at the structure of the IAS computer. All computers nowadays are based on the stored program concept. That's why John von Neumann is also very popular. Okay. So the popular people in computing history, the most popular are Babbage and Countess Augusta Ada King. You will have Alan Turing, and you will have John von Neumann. Sana kasali dyan si Vincent Atanasoff and Clifford Berry, no? Lightly, no? But not the same level. The biggest contribution was from John von Neumann in terms of modern computing. Do you follow? We will look at that, no? And then we will also do sample programming in the IAS programs. Okay? Okay. Any questions so far? Okay, hindi tayo nag-spill over today, no? We will not, I will not go further, no? Because we'll have a completely different topic by next meeting. Okay? 10:50. So we are 20 minutes ahead of time. If you have no questions, no? Questions, by the way? Okay. Let me review the attendance. Jemris, Advincula. Ano tayo? Kent, Elrond Aspa, Kent. Javon Berdin. Javon. Dwight Anthony Bumaat. Dwight. Rich Aliza Campos. Quison German Quison. May Angela Espera.
Present po, sir.
Rafael Vince Fernandez. Stephen John Jimena. Stephen. Cheyenne Kersolov. Angel Gabriel Litub. Angel Gabriel Litub. James Paul. Tisha Rael Pusta. Okay. So any questions? Okay. So our next meeting will be on Tuesday, right? Where we will discuss the assignment and a new topic on stored program concept. Okay. If you have no questions, then we'll have to dismiss. Bye for now, everyone. Everyone.
Bye, sir.
Bye,
Thank you,
sir.
sir.
Thank you,
Bye,
sir.
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 Thank you po.
Okay, thank you.
Thank you po, sir.
Thank you.